An AI chatbot just told someone the wrong answer. Not a vague answer, not a partial answer. A completely wrong answer, delivered with the same calm authority as a professor who has taught the subject for 30 years. This is called AI overconfidence, and it is one of the most dangerous failure modes in modern AI systems. By the end of this video, you will know exactly why it happens, how to recognize it, and how to protect yourself from it. Most people assume that when an AI sounds certain, it has checked its work. That assumption is wrong. Confidence in a language model is not a signal of accuracy. It is a signal of fluency. The model has learned to produce language that sounds authoritative because authoritative language appears more often in high-quality training data. The training process optimizes for how text sounds, not for whether the text is true. Think about the kind of text that exists on the internet and in books. Articles written by confident experts. Academic papers with declarative claims. News writing that states facts without hedging. All of that confident prose gets fed into the model during training. The model learns the patterns of confident language, not the patterns of verified truth. So confidence becomes a stylistic habit, not an accuracy signal. There is a technical concept here called calibration. A well-calibrated model would be right roughly 90% of the time when it says it is 90% confident, and roughly 50% of the time when it says it is 50% confident. Most large language models are not well calibrated. They are overconfident. The gap between how certain they sound and how often they are actually correct is large enough to cause real problems. Researchers have studied this gap extensively. Studies comparing model confidence expressions against factual accuracy found that models frequently assign high certainty to answers that turn out to be wrong. In some benchmark tests, models expressed maximum confidence on answers they got wrong more often than on answers they got right. Let that land for a moment. The most confident responses are statistically the most suspect. To understand why this happens at a technical level, you need to understand next token prediction. Language models do not think through a problem and then write an answer. They predict the next word, then the next, one piece at a time. Each prediction is based on the statistical patterns in training data. There is no internal fact-checking step. There is no pause for verification. The model just keeps predicting the most plausible-sounding continuation. When the model is in territory where the training data was sparse or contradictory, it does not slow down. It does not flag uncertainty unless it has been specifically trained to do so. It keeps producing fluent, confident text because that is what the statistical patterns point toward. The output sounds authoritative precisely because the model cannot tell the difference between what it actually knows and what it is pattern matching toward. This is where hallucinations come in. An AI hallucination is not a random glitch. It is the natural output of a system that generates plausible text without grounding in verified facts. When a model invents a citation, a statistic, or a historical event that never happened, it is not malfunctioning. It is doing exactly what it was trained to do, which is produce fluent, coherent, confident-sounding language. The hallucination is a feature of the architecture, not a bug. Real examples of this are not hard to find. Lawyers have submitted AI-generated legal briefs citing court cases that did not exist. Medical information platforms have seen AI summaries state drug interaction risks with total confidence that were fabricated. Developers have used AI-generated code explanations that described functions doing the opposite of what the code actually did. In every case, the wrong answer sounded more authoritative than a careful human answer would have. There is a psychological dimension to this problem as well. Humans are wired to find confidence persuasive. When someone speaks with certainty, we lean toward believing them. This bias was useful in human social contexts, but it becomes a liability when we apply it to AI outputs. The model sounds certain because it was trained on certain-sounding text, not because it has earned that certainty through accuracy. Some newer models have been trained with techniques that are meant to improve calibration. Reinforcement learning from human feedback can push a model toward expressing uncertainty more honestly. But this is not universal, and it is not always consistent. A model that hedges well on one topic can still be overconfident on another topic where its training data was thin. You cannot assume that because a model hedged once, it will hedge when it matters most. So how do you actually catch an overconfident AI response before it causes a problem? The first technique is to ask the model to argue the opposite position. If you ask an AI to make the case against the answer it just gave you, a well-calibrated model will produce a reasonable counterargument. An overconfident model will often struggle, contradict itself, or simply repeat the original claim in different words. The second technique is to ask the model where it is uncertain. Not whether it is uncertain, but where. Phrase it specifically: what parts of this answer are you least confident about? A good model will identify genuine weak spots. A poorly calibrated model will say something like, "I am confident in all parts of this answer," which is itself a red flag. No answer about a complex topic has zero uncertainty. The third technique is source triangulation. Before you act on any high-stakes AI output, find 2 or 3 independent sources that confirm the core claim. This is not about distrust for its own sake. It is about recognizing that the model's confidence is not a substitute for verification. If you cannot find independent confirmation, treat the AI's answer as a starting hypothesis, not a conclusion. There is also a pattern worth learning to recognize in the text itself. Overconfident AI responses often have a specific texture. They state exact numbers without ranges. They make universal claims without exceptions. They describe complex situations without acknowledging trade-offs. When you see an AI answer that has no qualifications at all, that is not a sign the answer is correct. That is a warning sign worth investigating. The implications of this go beyond individual users. Organizations that are deploying AI at scale, in customer service, in content production, in legal review, in medical triage, need to understand that AI confidence scores and confident-sounding outputs are not reliability signals. Building workflows that treat AI output as final rather than as a first draft is one of the most common and costly mistakes being made right now. The good news is that awareness itself is a protection. The moment you stop reading AI outputs as authoritative and start reading them as probabilistic drafts, your ability to catch errors improves significantly. The model did not become less confident. You became a better reader of what that confidence actually means. AI tools are genuinely powerful. This video is not an argument against using them. It is an argument for using them with an accurate mental model of how they fail. The most dangerous user of any AI tool is not the skeptic who checks everything. It is the person who has learned that AI sounds smart and has stopped asking whether smart sounding equals correct. If this video changed how you think about AI confidence, do this channel a favor and hit the like button. It genuinely helps more people find this content. Subscribe if you want a clear-eyed look at how AI systems actually behave, not how they are marketed. Next week we are covering a related problem: why AI models often get worse at a task the more you ask them to explain their reasoning. That one will surprise you.